Hello everybody. In this lecture, we will study about intermediate and high moisture fruit products. Okay. The concept that we will discuss here, that what are intermediate moisture foods, what are the different technologies for production of intermediate moisture foods, technologies for preparation of different intermediate moisture food are with some examples, then novel technologies for preservation of IMF, then high moisture fruit products and processing and preservation of high moisture fruit products. So, let us see first what does an intermediate moisture food means. Okay. That is, intermediate moisture food typically contain moisture content somewhere in between 20 to 50%. Okay. They also have a lower water activity. Their water activity is in between 0.75 or 0.85 in general, but it may vary. The products are generally considered as microbiologically stable at room temperature. In general, the intermediate moisture food maintains some certain initial characteristics like color, texture and flavor of the fresh products. The unique features that makes intermediate moisture food appeal to consumers include conceived microbial safety, desired colors, odors and nutritional value, and they are generally ready to eat form. So, you can see here that the water activity, that is maybe sometime 0.7 or 0.6 and above, and up to even 0.85 generally, but in this figure is shown 9. So, this is considered as a range of the intermediate moisture content. These are some of the products made from papaya, pineapple, apple, banana. They are available in the market, these intermediate moisture foods. So, basically the purpose of the intermediate moisture food is to achieve a desirable water activity by various ingredients, so that the food products maintain enough water for palatability and can be stored safely. The addition of preservative provides the margin of safety against the spoilage microorganism. Even Staphylococcus aureus is one of the organism of high concern in these cases, because it can tolerate AW as low as 0.83 to 0.86 under aerobic conditions. Okay. So, in this figure there are various the water activity level and relative rate of the various reactions as well as microbial growth etc. are shown. This earlier also we discussed this aspect. So, various some of the common example of intermediate moisture food, particularly the intermediate moisture fruits products include jam, jelly, candies, baked goods, honey or even partially dehydrated or semi-dried fruits and vegetables. So, this is an overall process technology for the development of intermediate moisture foods or high moisture fruit products. You can take the raw material, then common treatment like selection, washing, cutting, peeling, then washing and weighing. Then it is a blanching, depending upon whether it is a fruit or vegetable, one has to go blanching, appropriate blanching for the inactivation of microorganisms etc. so that get proper color. Earlier we discussed these aspects. Okay. Then after blanching it is soaked, maybe addition of syrup and other additives, that is in the case of fruit we add syrup of particular concentration. Then we allow, it is given some time last for 5 to 10 days with gentle stirring at least twice a day, and this is for equilibration and getting the water activity in normal form, that is maybe up to 0.93 to 0.98 and pH is 3 to 4. So, after that this is separated using appropriate methods, like there is a separation, that is you can say the sweetened juice and juice is packaged, or even this after separation there is a fruit piece, it can be partially dehydrated. You can the intermediate moisture food packed in storage, or alternatively you can get self stable high moisture fruits packaging and storage. So, this gives an overview of the different process technology. Then examples of traditional intermediate moisture food products, particularly from fruits and vegetable origin, their water activity ranges and the principal humectants which are shown there. Like for example, you can say sugared fruits, their water activity is between 0.57 0.79 in the sucrose, or such other sugars are Honey is also considered an intermediate moisture food. It's 0.58 to 0.68 is the water activity. Here sucrose or other sugars may be present. Chocolate or even chutney sauce, its water activity is 0.86. Here sodium chloride or some food acids are used. In dried apricot or peaches, so water activity may be 0.73 to 0.81. Sucrose or other naturally occurring sugars can be used. So these are these examples. That is, the list is further exhaustive. You can find out from the literature. So the microorganism in this slide it is shown, that is how there is a different microorganism. They are separate, that is microorganism generally inhibited by lowest water activity in the range may be, for example, 0.8 to 0.84. Most of the molds like monocytogenic penicillia or Saccharomyces species etc., they are Debromyces, they get inhibited, they cannot grow. So it is done in the case of most of the fruit juice concentrate, chocolate syrup, maple or fruit syrup or fruit cake. These are the products which are preserved, which are brought, their water activity is brought to this level and they are microbiologically safe. Similarly, that is the water activity range of 0.75 to 0.8. Most halophilic bacteria are mycotoxigenic aspergilli, they are not able to grow, and this is the jam, marmalade, that is some marshmallows etc. are preserved during this. Water activity in the range is 0.6 to 0.65. Even osmophilic yeast like Saccharomyces roxai or few molds like Aspergillus or Monococcus biosporus etc., these are not able to grow. That is the minimum water activity for their growth. So it is, if it is brought below this, they will not be able to grow, and it is in the dry fruits containing 15 to 20% moisture or some toffee and caramel, honey etc. Okay. So fruits as IMF, intermediate moisture foods, that food can tolerate pH reduction without affecting flavor significantly. Minimum addition of humectant for AW reduction is required to maintain the freshness. So to compensate stability for the high moisture of the product, a blanching treatment can be applied. So pH reductions that will not result in the flavor impairment can be employed, because the pH, you cannot reduce pH very low, you cannot bring it, otherwise it will adversely affect the taste and flavor. So permitted preservatives can be used to reduce the risk of spoilage, or combination of these factors we studied in the last class, the hurdle technology, they can be applied, okay, to get the stability in the products. Okay. Low pH in the majority fruits and organic acids affect the growth of acid tolerant microbes. In fruits with high pH like in banana, melons, fig, papaya, the minimal pH adjusted should be compatible with the natural flavor of the fruit. Additional hurdles of incorporating preservatives, weak lipophilic acid etc., like sorbic acid, benzoic acid etc., may be used. Blanching step can be used, it inactivates the enzymes or injures microorganism, reducing the initial microbial load. Sulfiting agents are used in low concentration to inhibit the non-enzymatic browning reactions. Okay. So technologies for the production of intermediate moisture food, it may be conventional method like partial drying, moist infusion or osmotic dehydration, dry infusion or direct formulation, or even novel technologies like innovative drying like microwave drying, microwave convective air drying, combination of drying or infrared drying, or even water activity lowering agents can be used, or innovative osmotic dehydration technique like vacuum impregnation, osmodehydrofreezing, pulse electric field assisted osmotic dehydration, or ultrasound assisted osmotic dehydration can be used for production of intermediate moisture food. So partial drying, you can say that it can be used to produce IMF only if the starting materials are naturally rich in humectants. So dried fruits like raisin, apricots, prunes, dates, apples and figs etc., and syrups, maple syrup. So the final water activity of the product is in the range of 0.6 to 0.8. So moist infusion or osmotic dehydration, it involves soaking solid food pieces in a water humectant solution of lower water activity. So the difference in the osmolality forces water to diffuse out of the food into the solution, and simultaneously the humectant diffuses into the food, usually more slowly than the water diffuses out, and this is the process how the various candied fruits etc. are produced, or osmotically dehydrated fruit preserves are candied, and the process is shown schematically in the figure. Dry infusion consists of first dehydrating solid food pieces and then soaking them in a water humectant solution of the desired water activity. It is more energy intensive, but it results in high quality products, and it is used for preparation of IMFs for the NASA and US military. Direct formulation is another method, like it involves weighing and direct mixing of the food ingredient, humectants and additives, followed by their cooking, extrusion or other treatment resulting in the finished product of desired water activity. It is fast and energy efficient and offers great flexibility in formulation. It is used for both the traditional IMF like preserves, candies etc., as well as novel IMF like pet foods, snack products and so on. Then novel techniques for the preservation production of IMF include the microwave or combined microwave drying, like microwave assisted hot air drying, vacuum microwave drying and microwave vacuum freeze drying. This earlier also we discussed these aspects, or even infrared drying. It delivers energy the products via electromagnetic waves and wavelength between 0.75 and 1000 micro. So, this is it can easily be combined with other traditional drying methods for industrial application. Okay. Water activity lowering agents for intermediate moisture foods. The IMF can be produced by adding water activity lowering agents to reduce the amount of and mobility of the water, and accordingly to lower the water activity. So, lowering water activity prevents or hinders the growth of foodborne pathogens and prolongs the shelf life. It is an effective humectant, would ideally provide the following property, like it is non-toxic, exhibit adequate solubility in water, have a low molecular weight, so compatibility with the organoleptic characteristics, have low or no caloric value, reinforce dietetic image of the food by adding positive functional properties, and finally it should have low cost. So, some of the common water activity lowering agents which are used in IMF include sugar, low molecular weight polyols, protein derivatives or minerals and organic acids. Okay. Then water activity lowering agent, that one can calculate that what is the amount of the additive that to be required to be added to get the desired water activity. That is, water activity of an ideal solution is a direct function of the mole fraction of solvent component, that is AW is equal to XW. XW is the mole fraction of the solvent water, further equal to NW divided by NW plus NS, where NW is the total moles of water and NS is the total moles of solute or solutes. Okay. The AW of real solution is therefore equal to AW is equal to YW XW, where YW is the activity coefficient of water, and it is RAW can also be given by equation NW by NW plus YS NS, where YS is the activity coefficient of solute. So, by using these equations one can calculate that what should be the amount of solute required to be added to get the desired water activity. So, for ideal solutions YS is unity, generally for humectant Y is S is greater than 1 and YW is less than 1. Okay. The smaller the molecular weight of the humectant or solute, the greater is the its AW lowering effect per unit weight of the material dissolved. Okay. So, some of the novel dehydration techniques for production of intermediate moisture food include vacuum impregnation, that is combining vacuum impregnation with osmotic dehydration, facilitate penetration of osmotic solution into porous structure of plant tissues in a controlled manner. So, it is a time saving and there is a better retention of nutrition and fresh sensory qualities without exposing in oxygen and faster penetration rate. The system experimental setup for vacuum impregnation is shown here in the figure. Similarly, osmodehydrofreezing, this aspect also we discussed in the earlier class also in detail, that is it is used to produce IMF with better textural properties and reduced structural collapse. A unique advantage of this combination is that osmotic dehydration removes a part of water in fresh foods and thus reducing the available water for freezing and minimizing quality changes in fruit products upon thawing. So, that is a better alternative. Similarly, PEF assisted osmotic dehydration, it significantly enhanced antioxidant capacity, phenolic content and color retention of the, and there is a decrease in total processing time by 33% compared to the conventional drying method, because the PEF before putting to the osmotic dehydration facility, if you just give a short PEF treatment, it causes poration, and because of the electroporation the material transfer characteristics etc. That is water transfer and other transfer characteristics is. So, there is a low processing time and faster protein digestion, okay, enhanced mass transfer etc. is there. Similarly, ultrasound assisted osmotic dehydration also works. US are mechanically waves with frequency ranging from 20 kilohertz to 100 megahertz, where that can transmit through solids and liquid media via alternating volumetric expansion and compressions. It facilitates the removal of water from food materials, thus shortening the time of osmotic dehydration, improving energy efficiency and enhancing the product quality. And here also that ultrasound, it causes cavitation etc. proves. So, this is a flow diagram for preparation of jamun candy, and this that is take jamun fruit, cleaning, pulping, filtration, addition of ingredient, mixing, concentration, spreading, cooling and cutting into different cubes. So, various methods which we have discussed earlier, that can be like for drying and spreading etc. This is the ingredient per kg of the fruit pulp is recommended. So, these are all taken from the literature. Similarly, a process flow chart for preparation of apple jam, it is a very common product. So, it is again go for the preparatory steps, then peeling, pulping, remove the seed and core, addition of sugars and boiling with continuous stirring. Okay. After boiling, then addition of citric acid, judging the end point like by further cooking up to 105 degrees Celsius, or by taking once the TSS is by 68 to 70% bricks, or by there are different tests, seed test etc. So, once it is means the product is ready, then filling hot into the sterilized bottles, cooling, waxing and then capping. So, these are similarly, this is the preparation of jelly. It is also almost same, but only thing is that here that in that earlier case it was pulp, here is the boiling the material, that is cutting into thin slices and then boiling with hot water, then addition of citric acid while it is being boiled, that is 2 gram per kg of the fruit, straining the extract, and this extract is tested for its pectin content, because the pectin should be good in quantity for proper set of the jelly. Then accordingly, once you find out that whether low pectin, high pectin, either pectin may be substituted, and accordingly suitable quantity of sugar is added, this is further boiled, and then judging the end point. End point, that is the seed test or spoon test etc. is added. There are some standard tests in the, they are given in the books, this is very common, you can read from the books etc. Then finally, removal of scum or foam, filling hot into the clean sterilized bottle, waxing and capping and finally storage. So, these are standard methods for preparation of jam. Similarly, marmalade, it is the same, only difference is here, just like jam it is prepared, and only difference is that is here the shredded, that is peel, shredded peel and softened peel, there is a small quantity of peels also they are added here. So, preparation of fruit, pulp extraction, pectin testing, cooking, and at the time of when it is cooked, then shredded peels softened is added, and then rest process is the same as like that of jam or jelly. Then this is a preparation of carrot cake, weighing of dry and wet ingredients. Okay. Fat and sugar are creamed in plenty mixtures, then eggs are added at the rate of 5 regular intervals to ensure proper mixing of the eggs with that, and also proper whipping of the air. Then maida flour, shredded carrot, baking powder, vanilla essence, etc. are added. This all placed in a tray and bake at 180 degrees Celsius for 35 minutes. Cooling, slicing and packing. So, this you give say fruit cake or carrot cake, it is also again an IMF. Dates as an IMF, that is a harvesting of the dates from the farm, packaging of dates for the processing unit, sorting, removing of pit and cleaning of the dates, washing and drying, sorting and grading of fruit for uniform size date packing, metal detection, and then surface coating to minimize stickiness and that enhances the appearance, packaging, storage and transportation for the markets. So, these are the dates. Okay, they can processing of honey. In this slide is shown that yes, this is a continuous production and processing of honey, that is the fruit nectar, raw honey, screening, storing, filtering, dewatering, that is the clarifying. Once you keep, that is the water etc. that is clarified, then liquefaction, pasteurizing, cooling, filling, capping, labeling, packing, storing and finally delivery. So, because of the time shortage, it is not possible to explain in detail each and every stage and process parameters etc. But anyway, these are available in the literature and books. These are very age old standard practice. So, I recommend all the participants of the course to please read all these processes from the books or other literatures and get yourself well acquainted. Okay. This similarly again this mango leather, preparation of mango leather. It is taken ripe mango, wash, peel and extract the pulp and strain it, add 0.6 gram potassium metabisulfite for every kg of pulp and smear it continuously, properly mix it. Okay. And then smear the trays with edible oil, spread pulp in thin layer on the trays. Okay. Dry in mechanical dehydrator, be able to 70 to 80 degrees Celsius for 10 minutes and then add layer after layer of this mango leather. After drying first layer, spread the second layer on it and then repeat this process until thickness of the sheet is maybe 1 to 1.25 centimeter, several layer is put. Then cut dried sheets into pieces of suitable sizes, wrap in waxed paper and store. So, that is the mango leather intermediate moisture food. So, technologies, novel technologies for the preservation of intermediate moisture foods include that is an sterilization or packaging or huddle technology concept. Sterilization can be done using high pressure processing, plasma treatment or pasteurization. Okay. Packaging like edible coating, active packaging, modified atmosphere packaging etc. can be done, and huddle technology concept obviously we studied in detail in the earlier lecture. So, all those things can be applied. Okay. These are the some of the, you can see that how it is shown that it is the sapodilla fruit and this is it is the thermally processed jam of sapodilla or it is high pressure processed jam. So, you can see, check the difference, that is how its color and other attributes. High pressure processed jam showed better retention of bioactive components as well as stability as compared to thermally processed jam. Okay. Then high moisture fruit products. This is a very unique combination, that is the huddle technology concept can be used to produce high moisture fruit products, that is fruits with having water activity as high as 0.98 can be stabilized using combined huddle technology. The pH, preservatives and other factors, high pressure, blanching and all those things. So, the pH exert a strong selective pressure on the existing microflora. pH ranges of high moisture fruit products are generally in the 3 to 4.1. So, in this range it might not be present for the optimum growth of microorganism, because it this pH is very low, and for general pathogenic microorganism, soil microorganism will not grow under this pH. So, pH AW interaction in the applied ranges will be enough to suppress the growth of most bacteria of concern in fruit preservation. At high levels of water activity, the effects of pH on osmotic yeast might be the same as for non-osmophilic yeast. Okay. For the preservation of high moisture fruit products, we discussed detail in the hurdle technology in the last lecture. So, the common hurdles, obviously depending upon the what is the fruit, its nature, what are its components, what is acidity, etc., various hurdles which can be used to stabilize microbial stability of HMFP are blanching, water activity depression, lowering of pH, addition of chemical preservative, maybe sorbates or benzoates, and the addition of sulphite as an anti-browning agent. So, either all or combination of these can be and proper. Okay. That is the intelligent combination of these hurdles is important. So, microbial stability could be achieved with an intelligent combination of these hurdles, and the food will be stable even if it is a very high water activity, but it will be stable at room temperature. So, food is preserved by interference with the homeostasis of the microorganisms. Again, this aspect we studied in detail in the hurdle technology lecture. What is the mechanism? That is, homeostasis is the tendency of uniform stability in normal status. Okay. It is so, homeostasis is disturbed by the preservation factors, and the microorganism will not multiply, or even eventually it will die. Okay. So, here the processing technology, some of the self stable high moisture fruit products. Okay. Shown, that is the selection of the fruit, washing, peeling and cutting. Okay. Then blanching step, that is the saturated steam maybe for 2-3 minutes, followed by water cooling. So, fruit is after it is peeled, cut into slices, then it is blanched, and after blanching it is given product equilibrium. Then addition of sugar, acid, potassium sorbate, sodium bisulfite, etc., into the required quantity. Okay. And then here wet or dry infusion at atmospheric pressure, it is done. So, finally, that is after the product equilibrium time is allowed, the conditions are properly maintained. So, the water activity becomes in the range of maybe 0.94 to 0.98. Accordingly, one can, as earlier I told you, gave you the formula. By this one can calculate how much the sugars, how much the potassium, that is other additives setup might be required to get the desired water activity. If you know the initial water activity of the material, or what is the water amount of water present, mole fractions of water, etc. Then finally, the water activity is in the range of 0.94 to 0.98, pH 3 to 4. Okay. Then here 400 to 1000 ppm of potassium sorbate, or 100 ppm sodium bisulfite. So, this becomes sufficient. So, the fruit pieces are poured into glass jars or polyethylene bags filled with syrup, and finally packaging. So, this arrangement will make this fruit with such a high water activity, and it will keep safe at a room temperature without any refrigerator for longer period of time. Then similarly, self stable high moisture mango slices, especially mango slices, that is the mango slices, mango is peeled, small stone removal, etc. Then slices are blanched, again super saturated steam for 1 minute, and then cooled. It is after blanching, water is cooled. Then addition of sugar, potassium sorbate and sodium bisulfite. Water activity is maintained to 0.97, pH is 3, 1000 ppm potassium sorbate and 150 ppm sodium bisulfite is required. So, slices are packed into polyethylene bags or glass jars, and slices are covered with syrup. That is very important. That is in these cases, that is the syrup should be the slices, direct contact with the slice with the air, etc., should be avoided. So, this should be always covered with the syrup. It is stored at 35 degrees Celsius for 4 to 5 months. Okay. Similarly, self stable high moisture papaya slices, the papaya peeling, seeds removal, etc. Blanching in saturated steam for 30 seconds followed by cooling. Then sucrose is added to get the 60 bricks TSS, 0.1% potassium sorbate, 5% citric acid, and the ratio of fruit to syrup is 1:20. Okay. Water activity is 0.97, pH is 3.7, and 1000 ppm potassium sorbate and 150 ppm sodium bisulfite. And then, like in earlier case also, here also the slices are packed into polythene bags or glass jars, and they are covered with syrup in this jar. Care is taken and is stored for 25 degrees Celsius for 3 to 8 months. These are the reports. So, finally, I would like to summarize this lecture that intermediate moisture food products, that is, are foods with moisture content higher than that of the dry foods, and they are edible without rehydration. That is important thing here. The unique feature that makes IMF appeal to consumers include conceived microbial safety, desirable odors, high nutritional value, and their ready to eat nature. Inhibiting microbial growth on a given substrate is not achieved exclusively by lowering the water activity, but rather it is a function of all contributing hurdles, that is water activity, pH, temperature, oxidation reduction potential, preservatives, or other, even the existing microflora, type of microorganism present, their quantity, etc. So, the shelf life of IMF can be extended by inhibiting microbial growth, reducing lipid oxidation, and preventing the contact of food materials with the outer environment. That is very, very important factor. So, the high moisture fruit products can be stabilized using combination of different hurdles that can affect homeostasis. These are the references for used in this lecture. Thank you very much for your patience hearing. Thank you.